Dear friends, welcome back to my video lecture series. In this video, we'll discuss a new topic, new unit. It is numerical solutions of partial differential equations. Partial differential equations, PDE. And also, we will discuss some basics and the classifications of PDE we are going to discuss in this video. Right. Introduction. So, partial differential equation occurs in many concepts. It plays in a major role in applied mathematics and engineering and everything. Not I am going to read the concepts fully. You just go through that. I will tell you what are the important concepts are there. So there are a lot of partial differential equations we have that we can't be able to solve analytically. Like for a few examples I have given here. Applied elasticity, theory of plates and shells, hydrodynamics, quantum mechanics, everything. First, we are going to uh, change into partial differential equation, and analytically it will be very difficult to solve. That's why we will convert to numerical. We are going to solve it in a numerical way. While you are solving for numerical way, we are going to convert that to the differential equation to a difference equation. That one only I have given in the theory. If you want, you can read it. Differential equation to difference equation, and then we will use some iteration process or a direct method also there. That one only we are going to study in this unit. Right. First, Richardson found this. He used this concept in his work. Later on, Libmans. We are going to use that concept only to solve the first model, Laplace model. We will discuss about that deeply later. Thereafter, Libmans improved this concept. That's it. These are all the introductory parts. Now, as I told you already, all differential equation we are going to convert into different quotients or different equations. Okay, we are going to convert like that. Then we can solve with the help of several methods. We can obtain the solution for the PDE with the help of several methods. And initial thing is we will classify the PDE into three kinds. It will be elliptic, parabolic, and hyperbolic that we are going to discuss later in this video. Thereafter, we have several methods. For elliptic equation, we have separate methods, and parabolic we have separate methods. Using one method, we can't. It will be very difficult to solve all kind of problems. So we are going to segregate the partial differential equations into three kinds: elliptic, parabolic, and hyperbolic. And we are going to use some methods to get the solution for that. That is what we're going to discuss in this video. Right. Now, differentiation, you know very well, dy by dx equivalent to limit h tends to 0 f of x plus h minus f of x divided by h. You studied that. So that concept only we are going to follow. It's not analytical way. That differential equation we are going to write as a difference equation. That one only we are going to call it as difference quotients. Right. It is nothing but y of x plus h minus y of x divided by h. This h can be written as again here x plus h, here x plus h, here h, here x. So that's why we are rewriting like that. That's what I have given here in the definition. Here, difference quotient is the quotient obtained by dividing the difference between the values of a function by the difference of the corresponding value of the independent variable. This one only I have given a sentence there. So this is the way to define difference quotient. This is first derivative, right? Here, they are going to use the Taylor series methods only to derive uh, the formula for the first derivative, second derivative, and third derivative, everything. Difference quotient concept we are going to derive now. Derivation I am going to uh, give here. If you want, if you are interested, tell me. Comment. Just type in the comment box. I will include a separate video for that. I will add a separate video for that. The main purpose of explaining this concept is if without explaining this concept, if I move to the topic Laplace, hyperbolic, and parabolic, there we were changing the normal differential equation using this different concepts only, we will derive some formula. Without knowing that, if I am explaining, you can't be able to understand the concept. That's why, that is the only reason I am explaining the concept here. Directly, I'm going to give the formula. What is the different quotient formula for first derivative, second derivative? I am explaining here. Ux of x naught, y naught. The similar way we are going to derive this. This is forward difference approximation for ux of x naught, y naught. Similarly, we can find backward difference approximation for u of x naught, y naught. Backward difference means we are going to, in forward difference, we are going to fix y, there will be the variation in x. In backward difference, there will be the, we are going to fix x, there will be the, we have to fix x, there will be the variation in y. That's what the meaning. Look at that. Yeah, with respect to x, with respect to, if you are doing both the forward and backward, we are doing. We are doing with respect to y. With respect to x, we are keeping y as a constant. Look at that. There won't be changes in the y value here. Suppose if you are doing with y, we will keep x as a fixed one, because more than one independent will be there. How to define PDE? An equation which contains more than one independent variable, like x, y, for example, u of x comma y comma z, the function. It's having more than one independent variable. It's going to call partial differential equation. So we are uh, deriving for one variable, we have to fix the another variable as a constant. So ux of x naught comma y naught in forward sense and backward sense, right? Similarly, if you keep x as fixed and y to vary, what we get? We will get uy. Or this is for forward aspects, this is for backward aspect. Uy of x comma 0. Similarly, we can derive for u double x, means second derivative with respect to x. U double x means what, guys? Here, dou square u by dou x square. That's what the meaning. That one only they are going to write u double x. Similarly, for u double y, we can derive this. Right. Here, del x represents, that is in the x direction, it will be h, del y represents its k. The grid points and the mesh point, I will explain with the help of the following diagram. That one only they have given here. Look at that. The previous one, what we have done there is, we are going to fix this one. If you fix x-axis and if you are varying y, we will get derivative of y, second derivative of y like that. If varying x, we will get a ux, u double x like that. This is what the thing they have mentioned there. Here, what they're in x direction, the difference is h. In y direction, difference is k. So now they are going to change x by ih, y by j into k. And for a future reference, it will be important one. In this one, look at that, x comma y is there, x h, x equal to ih, y equal to jh. Here I comma j only they have written because the uh, mesh length, this length is 1 unit. That's why h value 1, k value also 1. 1. That's why I comma j, I plus 1 comma j. Suppose if you are having a point here, it is I comma j. This is the direction, take the direction axis. Then what about the next position? Conformly, it will be I plus 1 comma j. What about the left hand side one? It will be I minus 1 comma j. This one only they explained in this diagram. So now if you are changing x by ih, y by jk, look at that. As I told already, x by ih, y by jk, we can get ux, we can define ux as this. This one only we are going to use in the upcoming topics. Ux, first derivative of x of u with respect to x. Similarly, this is backward, this is forward sense, this is backward sense. What we derived already. Ux with respect to x naught, y naught, in that way we have done. Now it will be I comma j. Right. Forward difference of y will be this. Backward difference of y will be this. Similarly, we can do the second derivative, u double x equivalent to this, u double y equivalent to this. I have given forward sense. If you want to derive backward sense also, if you want to refer, you can go through the textbook. So that formally, whatever the I have given, just mark the, I put tick mark. That another important one. Not we are going to analyze everything. In future also, we are not going to derive everything. Easily you can understand with the help of the diagrammatic representation. I will explain the concept in the easiest way. Fine. So these are all the things we are going to substitute to derive or not derive. No, yeah, to find the solution, we will substitute the derivatives and we will get one formula according to the method, whatever we are going to apply. Then we can get the solution for the partial differential equation. Fine. Now come to the second part, classification of partial differential equation. How to classify a partial differential equation? Particularly it is second order. Second order partial differential equation. Look at the general form I have given here. A into dou square u by dou x square plus b into dou square u by dou x dou y and c into dou square u by dou y square plus d into dou y by dou x plus e into dou y by dou y plus fu equal to 0. This can be rewritten as dou square u by dou x square, you know very well, u double x. Similarly, dou square u by dou x dou y is u xy. Dou square u by second derivative of u with respect to y is u double y. Similarly, first derivative of u is ux, first derivative of u is uy, fu equivalent to 0. Right. Now we have to classify it. The classification we are going to do in this part only. So second derivative of u with respect to x, dou square u by dou x square. Coefficient is a. So don't forget that. It will be important one to classify that. Uxy coefficient is b. Uyy coefficient is c. So this three things only going to make changes in the differential equation. Right. Now I'm going to find the discriminant b square minus 4ac. Suppose if I am having any equation, second order differential equation, I will find the value of a. What is a? Second derivative of u with respect to x will be a. Second derivative of u with respect to y will be c. Second derivative with respect to second derivative of u with respect to xy will be b. Clear? I'm going to take that one. I'm going to find b square minus 4ac. Suppose I am getting that value is it is negative. Then what will be? It will be elliptic. Suppose if I'm getting the discriminant value b square minus 4ac value 0, then what it is? Parabolic. Suppose I'm going to find the b square minus 4ac value, I'm getting positive. In your book, they will give less than 0, equal to 0, greater than 0, it will be like that. So positive value I'm getting, then what will be? Hyperbolic. That's it, guys. So simple it is. So choosing A, B, C will be important one. Don't do the mistake. Double x, I mean, second derivative with respect to x is A. With respect to x, y is B. With respect to y, y is C. Right. So if the discriminant value is negative, it is elliptic. Equal to 0, it is positive. If it is equivalent to, yeah, positive value, it is hyperbolic. That's it. This is the way we can classify graphs. Here, what about the nature of A, B, C, D, E, F, E, and F? Everything in general functions of X and Y. So it is elliptic if it is less than 0, that is negative. If you confuse with inequality, some non-major students, that is in 12th level, in the higher secondary level, they won't, without mathematics, they will study some courses. So for them, the inequality, identifying the inequality, it will be very difficult. That's why it is better to read like that, negative. If it is negative, it is elliptic. If it is 0, it is parabolic. If it is instead of greater than 0, it is positive. If it is positive, then it is hyperbolic. Clear? That's it, guys. So now we will solve some related problems in this topic. Some general general equation, most repeatedly occurring equation in real world situation. I have chosen some problems. I have given example for that. Elliptic type. Laplace equation. It's a familiar one. Laplace equation also you solved it. And the previous semester you studied a harmonic. If you want to prove a function is harmonic, it should satisfy the Laplace equation. That is u double x plus u double y equal to 0. Or the same thing can be written as what? Del square u equal to 0 or similar kind. So Laplace equation will be elliptic kind. Want to know how it is? What is the value of a? A equal to 1 here. What is b? B is dou x dou y. It is 0. What is c? C value is 1. Find b square minus 4ac. What will be? B value 0. B square minus 4 into 1 into 1. So what will be? Minus 4. Yeah, it is negative. If b square minus 4 is value is negative, then what it is? Elliptic. That's it. This is the way we have to classify, guys. Right. Second example, Poisson equation. So right hand side function, if it is there in the same Laplace equation, right hand side function, if it is there, it will be Poisson equation. And I will give this is elliptic type. I have given two more problems, two equations. In parabolic type, I will give one most repeatedly occurring equation. It will be one-dimensional heat. Why you have chosen this means you have studied in the previous semesters also. Could you remember one-dimensional heat? You will take a rod, you will heat on both ends, a rod of length length L, kept temperature A and B 0 degree Celsius, 40 degree Celsius until steady state condition. That concept. Analytically, you solved it there. Here, you are going to solve the same numerically. One-dimensional heat equation. Clue to identify that and all they may ask in MCQs also, guys. Be ready to answer for that. They will give the equation, this equation, this equation is known as option A, B, C, D. In that way, they will give. Be ready to solve such kind of MCQ questions also. Right. One-dimensional heat equation. I will give the clue. Most of you will confuse because we are going to solve such kind of the entire equation what I have given there in the upcoming each and every topics. So this is one-dimensional heat equation. This is second degree with respect to x. Here first degree with respect to t. One-dimensional wave equation also you studied. I will give that for. Okay. How it will be parabolic? What is your a in this equation? A value, second derivative is 1. B value, 0. Okay. What about C value? C value, second derivative with respect to y, that also 0. So therefore, B square minus 4AC. What will be? B value 0 minus 4 into A value 1, C value 0. So if you do that, it will be 0. B square minus 4AC will be 0. Then what would be? What will be? How to classify it? It is, yeah, exactly. It is parabolic. Got it. Right. Next, hyperbolic type. I will give an example for hyperbolic type. It will be one-dimensional wave equation. Would you remember a string, an elastic string, stretched and fixed into two end points, and you will disturb the string, and you will find the displacement of the string. That is what you have done in the previous semester, Mathematics 3, analytically. Now we are going to solve the same kind of problems numerically. Got it? Right. What about here? Most of you will confuse to classify it because you are having x and t. I explained with the x and y only previously ABC. So what is your a here? This is the equation. It is in x and t, not as it is in x and y. So our aim is to then what will be if you want to say dou square u by second derivative of u with respect to x is a. Then second derivative of u with respect to x and t, it will be b. If you are having instead of x, we are having x and t. That's what the meaning here. Second derivative of u with respect to t will be c. This is what, guys. So a equal to 1, b value 0, then c is equivalent to 1 by alpha square. 1 by alpha square, you can take a square also, won't be the issue here. So b square minus 4ac is equivalent to b square 0 minus 4, sorry, we have to take into the left hand side, guys, and then only we have to solve. Take it into the left hand side, which is equivalent to 0. The equation should be like that. See, look at that. In this way we have chosen. I will explain once again if you want. Look at that. All the equations are all the equations are in the left hand side equal to 0. In that way, you have to take it and then only you have to solve. Good. So you have to take into the left hand side equal to 0. So it will be, if you're taking this as minus a square, so it will be c is equivalent to minus, not for this equation. So now 1 by alpha square, it is a square you can take some other constant. So minus a square it will be minus a square. So b square value is 0 minus 4 into a value 1, c value is minus a square. So you'll get minus into minus plus 4a square. So if a is positive or negative also, it won't affect the answer. It is positive. If it is positive, b square minus 4ac value is positive, then it is hyperbolic. That's it, guys. This is the way to classify the partial differential equations. I have given few more problems for your better understanding. Classify the following differential equations. Yeah, f double x minus 2fy equal to 0. What is your a? A is 1. What about b? It is xy is b minus 2. What is c? Equal to 0. Then what about b square minus 4ac is equal to b square minus 2 whole square minus 4 into a into c0. So it will be 4 positive. It is positive. That is greater than 0. If it is positive, what will be? Hyperbolic. That's it, guys. Look at that. So positive, it is hyperbolic. That's it. Similarly, classify this ABC value, find b square minus 4ac. We are getting negative. It is elliptic. If you're getting with inequality, don't confuse it. If you're getting negative value, write negative. Negative means elliptic. Positive means it will be hyperbolic. Equal to 0 means it will be parabolic. Right. This is elliptic. Next, try to find here. A value 1, B value minus 2, C value 1. So 4 minus 4, it is 0. It is hyperbolic. Sorry, parabolic. 0 means parabolic. Similarly, another one I have given. Look at that. Only u double x equal to ut. Just before we discussed one-dimensional heat. Here 1 by alpha square is 1. So A is 1. B value u xt. It should be u double x. X and t it is there. U xt and u dt. This is A. This is B. This is C. Nothing is there. Only A is there. So B value, C value is 0. So it is 0. It is also parabolic kind. Similarly, try to practice for other problems also. Now come to this. Sometime they may ask for 4 more questions, such kind of problems. The previous one simply what you solved that and all will take place for MCQs. So x plus 1 variable is there, u double x coefficient. This is A. This is, what is B here? A equal to x plus 1. B is equivalent to minus 2 into x plus 2, including sign you have to consider. C equal to x plus 3. Then apply the formula b square minus 4ac. Apply a plus b whole square formula. Here multiply everything. The variable will cancel everything. Finally, you will get the constant. 4 only it will be there. The variable, whatever you are getting here, everything will be cancelled. Just expanded. So positive. Positive means what will be hyperbolic. Hyperbolic at all points. Then one more different problem. Here a is x, b equal to y, c value, sorry, b value 0, c value y. Then b square minus 4ac is equivalent to 0 minus 4xy equivalent to minus 4xy we are having. So look at that. They have given the restriction here. If the restriction is not there, we can we will get different cases. X or y 0 means parabolic. X is negative. Any one is negative means you will get positive value. You will get hyperbolic. In that way, we have to classify. But they have given the restriction. What is really? X is positive, y is positive. If x is positive, y is positive always, then what about? It will be negative alone. Negative means elliptic. That's it. Then another one different problem it is, and important one also. X square f double x plus 1 minus y square f double y equal to 0. So a value x square, b value 0, c value 1 minus y square. So substitute in the formula, you will get minus 4x square into 1 minus y square. This 1 minus y square I'm going to write y square minus 1, or multiply the negative inside. It will be minus, it will be positive, y square minus 1. I have written like that. So this is what my b square minus 4ac. How to classify? So we can classify into three kinds. If x, for all x is 0, what will be? X equal to 0, for all y, it will be b square minus 4ac will be 0. It will be parabolic. And when you are classifying other kind, you have to talk about this point. Y square minus 1 equal to 0. Then what about y square value? 1. Y equal to plus or minus 1. So if y is lies between plus 1 minus 1, what is going to happen? If y is greater than 1, less than minus 1, what is going to happen? Would you remember? Sorry, is it clear? Minus 1 to 1 y. So if it is lying inside, what is the nature? X is non-zero, x 0 we have given. Suppose if it is lying outside this side, greater than 1, less than minus 1, what is going to happen? In that way we are going to classify here, guys. This will be important one, right? So for x is equal to 0, for all y, for all y means what? Y equal to 1 also, you will get the same thing. You will get 0, b square minus is 0, will get parabolic. Next, for all x, except x equal to 0, and y value, as I told you already, y square equal to 1, y equal to plus or minus 1, lying inside. Lying inside means what? Give 0.1, what will happen? Y value here 0.1 or minus 0.1, because y square is there, for both it will be same. Y value, it will be 0.1 square minus 1. You will get negative value only, minus 0.1. If you want to give minus 0.1 square minus 1, if you are giving like that also, it will be negative. Am I right? Minus 0.1 square will be positive, and then 1 is bigger one, negative value only will get. Always it will be negative. That is less than 0 means negative. Then it is elliptic. What is the other kind? Opposite of this. Y is less than 1. They have given. What is the opposite of this? Y is greater than 1. Opposite of this one. Y is greater than minus 1. Then y is less than minus 1. This is what they have given here. For this case, what will happen? Y is greater than 1. What will we have? 2. Give 2. 2 square. 4. 4 minus 1, 3. So it will be positive. For all x, it will be x square by only, except 0. 0 already we discussed it. So it will be positive. Give y value minus 2. Y is less than minus 1, minus 2, minus 3. This is positive. Then what will be? 4 minus 1, it will be 3. So it is positive only. So always it will be positive. Then it is hyperbolic. That's it, guys. So in this video, we discussed how to write the derivative as different quotients, first derivative as and second derivative, and we classified the PDE. The PDE will be classified into three kinds. What are the three kinds? One is elliptic, another one is parabolic, third one is hyperbolic. So now we are going to solve the problem for elliptic kind, parabolic kind, hyperbolic kind. Three major topics are there. We will discuss each and every one separately in the upcoming videos. Thank you, guys. If it is useful one for you, like it and share to your friends and subscribe it. Thank you. Thank you, guys.